Let's find a second moment of area about the centroid of this T section. Well, what we can do is break this up into two areas, being the area of the flange and the area of the web. And therefore we can use the following equation to determine the second moment of area of each of those areas about the centroid of the section. So for each rectangular section we have the width by the depth cubed on 12 plus the area of the section multiplied by the distance between the centroid of that area to the centroid of the section squared, using the parallel axis theorem. So therefore the second moment of area of the entire section about the centroid is equal to the contribution from the flange, so that will be the width by the depth cubed on 12 plus the area of the flange, which is 300 by 20, and then we multiply this by the distance of the centroid of the flange to the centroid of the section. So using geometry, you can work out that the distance at the top of the section is 98.9 millimeters. So therefore dcy is equal to 98.9 minus this distance over here, which is 10 millimeters. And that's squared. And now we add the contribution of the web. So that'll be 25 by the perpendicular dimension cubed. So that'll be 320 minus 20, which is 300 on 12. And then plus the area of the web. That's multiplied by the distance of the centroid of the web to the centroid of the section. So that would be 221.1 minus this distance over here, which is 300 on 2. And that's squared. So if you calculate this out, you'll get 1.4 by 10 to the 8. And assuming units of millimeters for this section, the unit will be millimeters to the 4. Now to calculate the second moment of area about the y-axis of the centroid, well, that's simply equal to the depth by the width cubed of each section on 12. So what we have is Iyy bar is equal to the width, which is the parallel dimension, multiplied by the perpendicular dimension to the y-axis cubed. That'll be 300 cubed on 12. And that's the contribution of the flange. Then plus the contribution of the web, which is 300 by the perpendicular dimension cubed on 12. So that gives 4.5 by 10 to the 7 millimeters to the 4. And here there's no parallel axes terms because the centroid of the flange and the web coincide with the centroid of the section. And as we can see, the second moment of area about the y-axis of the centroid is much smaller than that of the second moment of area about the horizontal axis, because there's a larger distribution of area in the vertical direction. Please subscribe, like and comment to help me reach more students.